depends on length of links. Okay, so how it depends on length of links, that we have to discuss. Okay, so here if we will observe, okay, so what we have assumed, there is a 4-bar mechanism, and this A is greater than D. If we are saying this link AB is going to work as a crank, so what is its meaning? So definitely, as they are saying it will work as a crank, its meaning is that it should complete full revolution. So we will find out what is the condition needed for it. Okay. So we will just move further, and here in this arrangement, this length A is greater than this length D. Okay. So if this link AB will work as a crank, what are different positions or what are different configurations for this mechanism that we will observe. Okay, so we will move further. Okay, and here now what we are going to see, different configurations which will exist. We will see different configurations which will exist if this link AB will work as a crank. Okay, so we will move. Okay. On screen, three combinations or three positions are shown. Why only these three positions are taken into account? Okay, because these are the critical positions. Okay. What is the statement? If link AB will work as a crank, it should complete full revolution. Okay. And now we are going to obtain condition when that link AB will complete full revolution. We are going to obtain condition for what? We are going to obtain condition for this thing. Link AB is working as a crank. So definitely, if link AB will work as a crank, what will happen? It will complete full revolution. So let us say if link AB will turn in this manner. So there will be one position when this link AB will be aligned with fixed link. So here you can notice the link AB is aligned here with fixed link. Okay. Now why we have considered this position? So we have considered this position because let us say if link AB will turn like this, and after some time it will be aligned with fixed link like this. Okay, we will have this B here, and we will have triangle like this. So what is its meaning? Its meaning is that if we will have this position, its meaning is that this link can turn from this position to this position. That is its meaning, and it is one of the critical positions. If this position can exist, what is its meaning? Its meaning is that link AB can turn from this position to this position. That is its meaning. So we have considered one more critical position. Okay. So here the critical position is shown. Now you can notice that first critical position is in the form of triangle, and we have considered one more critical position. Okay. So you can notice what is that second critical position? That output link CD will be aligned with fixed link. So same thing is shown. So this figure and this figure are same. Okay, only scale is used. Okay, half scale is used. Okay. So here, wherever this output link CD will be aligned with fixed link, arrangement will look like this. So this is also one of the critical positions. Okay. So this is also one of the critical positions. Okay. So that's why we are taking it into account. Okay. So it will also ensure that this link AB can move from this position to this position. Okay. Now one more possibility is there, and one more critical position will be there. So if that position will exist, then we will be sure that that position is shown here. Now, if you will observe it properly, and we will try to understand what is that position. Okay, just a minute. Here, AB is shown like this. So what is its meaning? This link AB can turn in clockwise sense. So if it will turn in clockwise sense, there will be moments when that link AB will be aligned with link EB. So B will be somewhere here. So at that time, what will happen to other links? So obviously other links will be on the lower side. PEC is shown here, and obviously CEB will be here. Okay. So obviously, even if mechanism will operate, length of links will not change. So same lengths are represented there. Okay. So length of AD is A, length of BC is B, length of CD is C, and length of fixed link AD is C. So here also same lengths are shown. Okay. Now, why we are going for this position? Because whenever link AB will work as crank, so there will be some critical positions. If those positions will exist, if those critical positions will exist, then what is meaning? Then its meaning is that this link AB can work as a crank. It can move to that critical position. Okay, or it can pass through that critical position, and geometrically it can pass through that critical position. That is its meaning. Okay, so now we will move further. If you will observe it, then again, where this position can exist. So again, we are seeing triangle. That triangle can exist only if every side of triangle will be smaller than summation of length of other two sides. Okay. So whenever we will have this critical orientation, so it is in the form of triangle. So this triangle can exist only when this length b plus a will be smaller than this length and this length. So if you are not comfortable with triangle and all those things, we can elaborate like this. Shortest distance between any two points is straight line. So definitely, this A plus D or D plus E should be smaller than B plus C, because shortest distance between B and A will be straight line, CD. Okay, so that's why A plus D should be less than B plus C. Okay, so similarly, what we can do here for next configuration, what we can write in next configuration, uh, very easily we can mention that uh, you can notice again this next configuration or next position is in the format of triangle. So again we can apply property of triangle, or we can keep in mind what is the shortest distance between two points. The shortest distance between two points is straight line. Okay, so very easily we can say B plus C, this B plus C should be less than B plus C. Okay. If this condition is satisfied, what is it meaning? Uh, this mechanism can exist in this position. Okay, same thing is applicable here. Now, in this last critical configuration, so why I am saying it as critical, because if that configuration will exist, at that time only this link AB, this link AB can work as a. Hello, good morning. Uh, Today we are going to discuss about uh, machine, a mechanism, and kinetic pair, kinematic link, and followed by some joint. Okay. Before we are heading towards the kinematic link, we are supposed to talk. We will discuss about machines. What is the machines? Machines are nothing but a certain devices which is used to transfer, alter, or to direct the forces. Okay. Means if you are having some input is given to you, and if you are converting that input into some output, and that output is converted with the help of some different types of mechanisms, okay, which are constrained together, which are combined together to, and that particular which is giving you the some output, and that part may be considered as an machines. Okay, so here you can see in the figure there is a one motor is given over there which can be considered as an
machine. Okay. Next, a mechanism. Mechanism is what? It is a machine is consist of a different types of mechanism which are connected together. Okay, and which are used to transform. Our objective of mechanism is to transforming the motion and forces from one source to the an output source. Okay, you can see in this figure there is one table is over there and which is connected with the help of some bodies. Okay, links are there. Okay, this power is supplied with the help of a motor to this pneumatic cylinder. Okay, and this table can be lower down and up with the help of these linkages together. So this is a part of a mechanism which is used to lower down or to raise or lower the this table over here. So this is nothing but a mechanism. Okay, before heading towards any mechanism we are supposed to first of all talk about a rigid body. What is meant by rigid body? We know very well that rigid body is a body which does not suffer any distortion, okay, or which does not elongate if you are applying any sort of any force. If you have, apply a tremendous amount of force over there, but the body does not distort or does not change its shape and size under any action of forces, such a body is nothing but a rigid body. And all the bodies we theoretically consider, and all the bodies theoretically consider them as a rigid body. But practically point of view, such bodies does not exist in the world. Okay. Then what actually exists? Are resistance bodies. What is the resistance bodies? Resistance bodies are those bodies which are rigid for the purpose they have to serve. It means over here I have shown a one belt, okay, and belt is mounted on the two pulleys. A smaller pulley is over there and larger pulley is over there. Okay, some input will be given to this smaller pulley, and output will be obtained from this output link, this output pulley. Okay, now this pull belt is over there, which is made up of a rubber or some elastic material. Okay, now it is serving over there. It won't change its shape and size after having an operation. If it is rotating at 1000 rpm, you can find out the power motion is going to be transformed from smaller pulley to the larger pulley with the help of this belt. Okay, and after a certain duration of a time you can see that there is no change in shape and size of this belt. Okay, it means that it is a very rigid body? No, it is a act as a rigid body, though it is not a rigid body. What it means? It means it is a resistance body. The purpose for which they are performing their operation and does not change in shape and size are considered as a resistance body, and that's why that is the difference. That in actual basis all the bodies which are existing over there are performing their operation in the where they are used, they are considered as a resistance body. Rigid body is an ideal concept, but in actual world there is resistance bodies are supposed to be present in the world actually. Okay, then a kinematic link. Kinematic link is nothing but we have considered a resistance bodies. These resistance bodies are used to transfer the motions, forces, okay, and these are used in case of a different types of mechanism. Okay, and these are called as kinematic. Kinematic means which are having some motion with them. So link may be defined as a member or a combination of a members of a mechanism which are connected together, okay, and having a relative motion between them. Means if I am consider one link over there which can be connected to the another part, another rigid body or resistance body, and having a relative motion between them, so that a motion can be transferred from one link to the another link, and in this way you are able to transform the power also with the help of motion. You can over here you can see in the figure. Okay, so and then there are types of links are there. Okay, how the types of links are there? Their links are over here. You can see that one diagram is drawn, seen, you can see there is a one a rectangular along with that circular at the end, you can see, and them two nodes are provided there. So this is considered as an one link. Okay, because one of the end is attached to the one part and another end is attached to the another part. Okay, and so that it will be connected connected to the two different links, which either on this side there will be one link will be there, on another side there will be another link will be over there, and this will be connected to the some different body, and this will be connected to different body. one input will be given to from this side and which will be used transform with the help of this connecting link, and that is why it is called as a kinematic link. Okay, now you can see there are three types of links are there. Which are these three types? A binary link, ternary link, and quaternary link. These are classified on the basis of how many nodes are provided to the link. Over here, one single body is shown having two nodes, so it is called as a binary. Why? Because it can be attached at two different nodes, or it can be connected to two different bodies at two different nodes. Okay. Generally, minimum there a link should have at least two nodes so that it can be take some input from one end and it can transfer this, whatever the input taken by this link from one end, it will be able to transform to the another end. And that's why it should have minimum two end. Okay. If you are can see in this figure, there is a triangular shaped body is over there. Okay. This triangular shaped body having three different nodes. Okay, it means that it can be connected at three different location to three different bodies, three other different bodies at three different location. Okay, so that's why it's considered as a tunneling. It is having three different nodes in the single plane body. In a single plane, this is a rigid body, okay, or resistance body as far as our one is, which is used to connect to the other members and having a relative motion between them, and that is called as a kinematic link. And this link can be of three different types. One is a binary link, which I've seen over here. One complete single body is over there, having only two different nodes are over there. Okay. Now second one is a triangular shaped body having three different nodes are there. It means that it can be connected to the at three different nodes to the three different bodies. And last one is a quaternary link. Quaternary, as you can say, quaternary link, one link with having four different nodes. This is a circle rectangular body, you can see that, and in that rectangular body there are four nodes are over there. It means that this single link can connect it to four different bodies at four different nodes. Okay, which can be used to transfer the motion at four different location. But as far as the link is concerned, it is only single link, it is also single link, it is also single link. Okay. Okay, next part is pair. When we say that pair, it should have two minimum links are connected together, and these two links should have a relative motion between them. Unless and until it is not a kinematic pair. Okay, if you are joined two links, okay, you have joined two links. This is the one link, another link is over. These two links are joined together at this particular location, and if you give the in motion to this link, then it can rotate or revolve about this particular point. It means that it can have a relative motion with respect to the one another, each other, and that's why it is a kinematic pair having a relative motion between them. You have seen the kinematic link. This red one is one link, this green one is another link. These are joined together at one location, but after joining they can have relative motion between them, and then they are forming a one sort of a pair over there. In order to form a pair, they are supposed to be a need of two different links, but they should have relative motion between them, and then it can be considered as a kinematic pair. Okay. Now next topic is types of kinematic pair. As far as the types of kinematic pairs are concerned, the types pair can be classified according to the three different criteria. Okay, classification has been done on the basis of three criteria. The first criteria is according to the nature of relative motion. How the when you are joined to pair at one location, they are classified according to the how the relative motion between them, how they are going to move relatively to each other. Okay. Next one is nature of contact, how the contact is between these two links exist, how the contact is existing in between these two links. That's what we have to discuss under this second category. And last one is according to the nature of mechanical constraint, how they are mechanically connected together. That is will be discussed under the third category. Out of these three, we will see it one by one. Okay. The first one, according to the nature of relative motion. First one is sliding pair. Okay. Under that heading, a turning pair. Second one is a turning pair. Third one, a rolling pair. Fourth one, screw pair. and fifth one is spherical pair. If you look at all these five pair, these are categorized under the heading nature of relative motion. Okay, first one is sliding pair, second one is turning pair, third one is rolling pair, fourth one is screw pair. Okay, now we'll see one by one how they are going to be differ from each other. Okay, next one, first one is sliding pair. In case of a sliding pair, if you connect two links, okay, pair means you are connecting two links. But if they are having a sliding motion related to each other, then that category comes under the sliding pair. It means that you connect two links together, okay, but relative motion between them, a nature of relative motion is of which type? A sliding motion. Then under that category, the pair is formed as a sliding pair. As far as the example is concerned, if you consider a rectangular rod in a rectangular hole, in this figure you can see a rectangular block is over there. In that rectangular block, a rectangular block is provided inside the rectangular. There is a one block. Inside that there is a slot is over the rectangular slot, and inside that rectangular slot, a rectangular block is provided. And in this rectangular slot, a rectangular block can be move up and down, or can slide. Okay, you can see it can be slide to and fro motion. In this in this case, you can say that under that category, it is a sliding motion present between these two links. First link is a block having some slot, and this is a rectangular rod. Okay, so this rectangular rod is sliding inside the rectangular motion over there. Okay, so that is comes under the category of a sliding pair. Next one is a turning pair. As we are discussing this nature of relative motion, how the motions are there. First one is sliding pair. The motion is a sliding one. Now the turning pair. It means that when one link has to turn or revolving motion about the other related to each other. Relative motion is either turning or revolving. Okay. Then under that category, the pair will be formed as a turning pair. Okay. First example under this category is nothing but a circular shaft revolving inside a bearing. If you can see that there is a bearing, this one, and a cylindrical shaft is over there, which is providing a collar at the end. These collars are provided so that it can restrict their to and fro motion. It means that they are restricting him to slide. So which you are restricting him to slide. So which motion is possible as it is a circular bar or circular crankshaft. Okay. So this rod is circular rod is rotating inside this bearing. It means that it's turn or revolving inside it. This is you can consider bearing as a link number one, and a crankshaft is a bearing, link number two. So this crank link number one and link number two forming a pair. Which type of pair? A turning pair. Why? Because it is rotating inside these particular holes bearing. Okay, and that's why it is a circular shaft revolving inside a bearing. The circular shaft is revolving inside the bearing. That's why the category is number is a relative motion is a turning, and that's why the pair is called as a turning pair. Third one is a relative rolling pair. When two links have a rolling motion related to each other, they forms a rolling pair according to the nature of relative motion. Once again, the motion relative motion is of a rolling type. That's why a rolling pair. Example, as far as the example part is concerned, if you consider a rolling wheel which is rolling onto the ground, then you can see that a pair which is formed between this ground and this wheel is nothing but a rolling pair. Okay, or you can see this is a wheel which is, and this link number one is nothing but a ground, and this roll wheel is rolling onto the ground, which is giving it's taking some clockwise rotation, and at this particular point you can see that they are forming a rolling pair. The link number one is the ground, link number two is the wheel. So that's why a pair formed between these two links will be a rolling pair. Okay, fourth one is a screw pair. Okay, if you have seen sliding motion, according to the sliding motion there is a sliding pair, and second one is a turning pair, and according to that there is a turning pair. But if you combine this turning as well as sliding motion together, then this will be a condition for a screw pair. Okay, You can see if two mating links have a turning as well as sliding motion relative to each other, then they are forming a screw pair over there. Example, lead screw or a nut on a lathe. Okay, if you are having a nut which you have to screw it up into the lathe, okay, you have to screw it up. Then you can see over here there is a one nut is inside the bearing, sorry, a lead screw or a nut on a lathe. You can see over here there is a screw, and that screw, when you are tightening this screw or if you are moving this screw, it will having a turning motion as well as it will having a sliding motion together. Once you are giving some sliding turning motion, while having a sliding turning motion, it can slide also. That's why the while having the turning motion, it can have sliding motion together, and that's why the pair forming is nothing but a screw pair. When you are tightening a screw into the wall, what you are going to do, you are going tightening with the help of a screwdriver. Okay, so what you are going to, you are just giving a rotation. Okay, you are giving a cylinder turning motion over here. Okay, if I am saying that over here you are tightening the screw, so you are giving a turning motion, but having a turning motion, along with the turning motion, it is sliding in a horizontal direction. That's why it considered as a screw pair. Okay, last one out of the nature of relative motion, that is a spherical pair. In the spherical pair, one of the link is in the form of sphere, which is turned inside a fixed link, which is also having a hollow sphere shape. Okay, as far as the example is concerned, ball and socket joints. What does it means? One link will be in the form of sphere and another link will be swell or turns around that spherical shape. Okay, one link you having ball and socket joint, or another example is a pen stand, or your mirror is having a ball and socket joint where you can revolve this mirror of your automobile, the mirror attached to your automobile, where you can see that there is a ball and socket joint. In that ball and socket joint, there is some spherical shape is over there, and that ball is fixed inside the spherical, which can be rotate or swell along this inside that fixed link, so that you can rotate it about 360 degree, and such type of pair forming over there is nothing but a spherical pair. Okay, so, according to nature of relative motion, you have seen five different pair. First one is a sliding pair, second one is a turning pair, third one is a rolling pair, fourth one is a screw pair, and last one is a spherical pair. These all are formed on the basis of their relative motion. In sliding pair, the rectangular block only slide. In this case, it's only having a rotation motion or turning motion. Over here, it is rolling onto the ground. Over here, it can be screwed up. Okay, it has having a sliding as well as a rotation or turning motion, and over here it is having a fixed spherical shape. Inside that ball is swirl or have a 360 degree of rotation, and that's why a spherical pair is over there. Next one is according to the nature of contact. Okay, according to the nature of contact, the first one is lower pair. What is my lower pair? According to the nature of contact, how the two links are connected together, whether they are having a surface contact or area contact between these two links. If the contact between these, nature of contact surface, either the surface contact is there or area contact is over there present between these two links, then that category is then that type is called as a lower pair. Okay, if you are having two links, if you are connected in such a way, then if there is a having surface or area contact between them, then it is a lower pair. As far as the example is concerned, shaft rotating in a bearing, nut turning in a screw, or universal joint, or if you have previously considered rectangular block which is inside the rectangular slot. Okay, that is also lower pair. Okay, as far as the, okay, over here turning pair, inside this is what a cylindrical bar which is inside the bearing. You can see over here it is touching this cylindrical bar is touching to the cylindrical bearing. Inside that there is a circular area which is making a contact with this circular bar. It means that having a surface contact between these two links. Link number one is this one, link number two is this one. If you are considering this, this is having a rotational motion over here. So throughout this rotational surface area, the surface area of cylindrical bar is touching the surface area of the bearing, internal surface area of the bearing over here, and that's why it is under the category of a lower pair. As well as nuts turning on a screw, same thing is applicable for a screw, as well as universal joint. Okay, these all are under the category of a lower pair, because in all these cases there is a surface contact is present, okay, or area contact is present in between them. Next one is higher pair. Okay, first one is called as a lower pair if there is a surface contact or area contact. Next one is higher pair if you are having a point or a line contact between these two links, which the two links which are attaching with each other and having a point contact or line contact between them, then that pair is called as a higher pair. As far as the examples part is concerned, for a higher pair, wheel, rolling wheel onto the ground, or cam and follower, some of the example of a cam and follower. Tooth gears, it means that when two gears are meshed with each other, they are also forming a higher pair. They are having, in case of a spur gear, in case of a helical gear, as well as spiral gear, there is a point contact or a line contact which is present between the two meshing gears. Okay, as well as ball and roller bearing, these are nothing but one of examples of a higher pair. Over there you can see that in the figure, rolling wheel having only point contact between these two links, link number one ground, and this wheel which is rolling onto the ground. If you are saying that there is a point contact and this point contact is along the axis of the shaft, if you are consider all this is inside, it is having only line contact present between them, so it is a rolling what higher pair, only having a point or line contact is present in between the two links which are which are making a pair over there. Okay, the next one is according to the nature of mechanical constraint. Okay, according to the nature of mechanical constraint, first one is a close pair. If you are saying that mechanical constraint, what does it mean? Whether they are mechanically held together or not. If they are mechanically held together, then this is called as a higher pair. Okay, the example are some of the cam and follower, all lower pairs, as well as nut turning on a screw or a universal joint. Okay, if you have seen in case of a circular bar inside a bearing, or a rectangular bar in a rectangular slot, in this case you can see that they are mechanically held together. As okay, in this case they are mechanically, if they are mechanically held together, then they are considered under the close pair. Okay, in this case you can see that there is a cam is provided, okay, and this is a follower over there. They are mechanically connected together. Okay, once they are mechanically connected together, no need to apply any another force, so that they will remain in contact throughout the operation. Okay, and under that category it is categorized under the close pair. It will be more clear from the next diagram. Okay, the next category is unclosed pair. It means that what unclosed pair, when you have form a pair, okay, and this pair, and during the operation this pair may lose a contact. Okay, and in order to when have a continuous motion to be transferred between the pair, we are supposed these two links should not be what should not their contact should not be you are not supposed to be there should be continuous contact between the two pairs which are which are between whom we have formed the pair. So what we have to do, we have to apply some external force, either that external force may be in terms of a spring force or some due to the gravity. If such type of things are required, then it is categorized under the unclosed pair. It means that over here in the figure there is a cam is over there following a follower. If you are rotating, the cam is rotating with a higher speed, then what is going to be happen? Because of some inertia, there are some chances that follower may lose the contact between the with respect to the cam. It means that there is an interruption in the power to be transferred from the input link to the output link. It means that you are required some sort of a gravitational force which is pulling the follower into the downward direction. Okay, it means that you have, once you have formed this mechanism, but at a higher speed, there may be chances that they may lose the contact. So what we have to do, you have to apply, either it may be come down because of the gravity, or you have to provide some sort of a spring over there, so that they will remain in contact throughout the power transmission, throughout the motion to be considered. And in this case, if you look at the cam is present inside the follower, they are never going to change, or they are not given, never going to break the contact between them. When you are forming a pair, it means that they are once you are mechanically held together, they are not going to break their contact. Over here, in next case, that is the unclosed pair, there might be chances this follower and cam may lose their contact. So, in order to prevent this contact throughout the motion to be transferred, what we have to do, you have to apply some spring force action, or due to the gravity this follower fall down and will be continuously in contact with the cam, and for that purpose you require a what you require a spring force, and that is nothing but a, what unclosed sphere over there. Okay, then types of joint. Okay, as far as the types of joint are concerned, there is are three types of joints are there. First one is a binary joint. What does it mean? If two links are joined at the same connection, okay, then it is called as a binary joint. Means what? This is the link number one and link number two. These are connected at one location at one point. Then it is called as a binary joint is present over there. Okay. Next one is ternary joint. What does it mean? Similar to the ternary joint, if three links are connected together, okay, at some junction, at some connection, then it is considered as a ternary joint. Okay, and one ternary joint is equivalent to the two binary joint. Okay, means you have to keep one of the link to be fixed. Okay, and consider link number 2 and 3 with respect to the link number 1, so that only two binary joints are present when there are three links are over there, so that there should be a, because if you have to fix this link, the link number 2 and link number 3 will have a relative motion with respect to the link number 1. It means that how many joints are there? Two binary joints are there only. And quaternary joint, if there are four links are connected at one joint, at one junction, then they are called as a quaternary joint. Every quaternary joint is equivalent to the three binary joint. How? It means that number of links are, if there are n number of links at one junction, then there will be n minus 1 number of binary joints will be present at that location. Okay, types of joints are classified on the basis of how many links are connected at a one junction. If there are only two links are connected together, then it is a binary joint. If there are three links are connected together at one junction, then it is a ternary joint. If four links are connected together at one junction, then it is called as a quaternary joint. So in this way, in today's lecture we have discussed about what is actually somewhat in description related to the machines, then mechanism, and then we have moved on to the rigid body, the resistance body, and then kinematic link, kinematic pair, and lastly a types of joint. Okay, thank you.